the top of the board, I'm just reminding you of the formula for the derivative of arc cosine. That's just because it's new. I will not be reminding you of this on exams and quizzes. We're given this equation, and we're asked to find the second derivative of y. So let's start by finding the first derivative. I'm going to take the derivative with respect to x of arc cosine of 2x and say that's the derivative with respect to x of y to the negative 2. That y is some function of x, so this is a function composition. Now, the left-hand side is also a function composition because I'm plugging in 2x to arc cosine. So what that means is when I take the derivative of that outside part, I'm replacing the x there with a 2x. So we're going to get negative 1 over the square root of 1 minus the quantity 2x squared multiplied by the derivative of 2x. That's going to equal, over here on the right, negative 2y to the negative 3 times the derivative of the inside part there is just y prime. Now on the left here, the derivative of 2x is just 2. I'm going to combine that with the negative 1 on top, so we get negative 2 over root 1 minus, if I square 2x, that becomes 4x squared. And that's going to equal, I think I'm just going to rewrite that as negative 2 over y cubed times y prime. Okay, now there was only one y in the original equation, so there's only one y prime. That's appropriate. When I solve for y prime, I basically want to divide by this fraction, which is going to have me multiplying by the reciprocal. So I'll be able to say that y prime is negative 2 over root 1 minus 4x squared times the reciprocal of this fraction, which would be y cubed over negative 2. That's actually fairly nice. Those negative 2's cancel, so y prime is just y cubed over root 1 minus 4x squared. We were asked to find y double prime. Okay, so y double prime looks like that's going to be quotient rule. Low is the square root of 1 minus 4x squared. D high will be the derivative with respect to x of y cubed. Minus high, that's y cubed. D low, the derivative, and since I'm taking the derivative of a square root, I'm just going to rewrite that as the 1/2 power. All over the denominator squared. Since I'm squaring a square root, that's just going to lift that radical. So we just get 1 minus 4x squared on the bottom. All right, let me clear some space here. So as I work this out, I'm going to move over to this side of the board. So y double prime is, we've got root 1 minus 4x squared. The derivative of y cubed, that's going to be 3y squared, y prime. Minus y cubed. The derivative here, this is a chain rule, so we'll have 1/2 1 minus 4x squared to the negative 1/2 times the derivative of that inside part, which was 1 minus 4x squared. And then that's all over 1 minus 4x squared. So let's see. This is going to be, I think I'm just going to bump that 3y squared to the front. So 3y squared root 1 minus 4x squared times y prime. Minus, let's bump the 1/2 to the front, 1/2 y cubed, 1 minus 4x squared to the negative 1/2 times the derivative here will be negative 8x, and then that's all over 1 minus 4x squared. Let's check. There was one y here in the original expression for y prime, and I only see y prime appearing once. But when I find the second derivative, I should be able to express it in terms of just x and y without having any y primes. And once again, I want to not have any complex fractions, including this sort of complex fraction in disguise, which is a negative exponent inside of a fraction. So what I'm going to do now is just recopy this, but I'm going to replace y prime with the formula that describes y prime in terms of x and y. I'm also just going to rewrite that as the reciprocal of root 1 minus 4x squared. We're going to have a complex fraction, and then we'll simplify it. So, right now we've got y double prime is 3y squared root 1 minus 4x squared times y prime, which is y cubed over root 1 minus 4x squared. Okay. Let's see. For this next term, I think I'm going to combine the negative 1/2 and the negative 8. That's going to become a plus 4. I'm going to just bump that x to the front. That's going to become xy cubed. And then we said we were going to write this as 1 over the square root of 1 minus 4x squared. That gives me that piece. And all of this is over 1 minus 4x squared. Okay, excellent. So I do have a complex fraction. What's actually kind of nice is that I've got two fractions inside of my fraction, but they actually have the same denominator. So to clear that complex fraction, I'm just going to multiply by 1 in the form of root 1 minus 4x squared over itself. And so let's see. I've got to distribute to this first piece, but that's just going to cancel with that. Actually, I could have, had I noticed, I could have canceled this one here, but I'd still have to multiply through by this to get rid of this root in the denominator. So either way, one of them cancels, and I get 3y squared root 1 minus 4x squared times y cubed. Let's just make this a y to the 5th. Okay, and then plus 4xy cubed, because here that root will cancel. Okay, then on bottom, I've got 1 minus 4x squared times the square root of 1 minus 4x squared. If you preferred, you could have written that all as the quantity 1 minus 4x squared to the 3/2 power. It's up to you how you want to write it, but here we have got our second derivative in terms of x and y, and without having any complex fractions or any negative exponents inside of a fraction. And that was our goal.